Good evening, everyone. Our next topic is measures of dispersion. Now we have discussed central tendency. The purpose of central tendency is to find average. And average is basically it's either mean, median and mode. So now the next thing is we have already computed the average. Now we just want to know whether the average that we have computed is representative of the series or not. So to check the significance of average, that average is significant or not, the next analysis, that is dispersion, we compute. So dispersion helps in identifying the relevance or significance of the average. Whether the average is significant, we can rely it or not. That is the purpose of dispersion. So let's continue. Dispersion basically computes the deviation of items. So dispersion computes the deviation of items among themselves and among average itself. How the items are deviating with other items or its average value. This is the task of dispersion. So dispersion basically computes degree of scatteredness. So basically it computes degree of scatteredness. What it means, like suppose we have items. We can say we have 8, 10, 12, 9, 11, 14. Now suppose I am taking a rough figure that my average is, suppose we can say my average is 10.5. So if my average is 10.5, so if you just look at the items, all the items are surrounded across it. Means the distance of item with its average value is very small. So in that case, the deviation is small. Like we say, if all the items are same, that means 10, 10, 10, 10, 10. So average is also 10 and all the items are clustered because all the items are same, then dispersion should be 0 because there is no deviation. They have the same views. So in this case the dispersion is 0. Now in this case we are saying our items are 8, 10, 12. So this becomes 12, 10, 22, 8, 30, 39, 50. So in that case our average is 10. So if I just look at the items, all the items are very close to average. So there is a minute difference between the items and the average. So in that case, there will be less dispersion, less deviation. But if we say the items are 90, 40, 30, 60, 50. So if we compute the dispersion, average, it's 270. 270 divided by 5. This is 54. So there is a huge difference between the items. So in that case, the dispersion will be more. So the thing is this, if the items and the average are very close, then dispersion is less. And if the distance between the items and its average is more, the dispersion will be more. So dispersion basically computes the degree of deviation. How items are deviating from its average value. Like if we say if a class selects the representative with everyone's opinion, then definitely the differences are less. So this you can say that dispersion means differences. So if we have a family in which all the persons are very close to each other, then the differences are less. In that case, dispersion is less. But if we have a family in which everyone has its own opinion and the opinions are contradictory, then there may be more differences. Then in that case, dispersion will be high. So the purpose of dispersion is to find out the deviation of items among themselves as well as across its average value. So if the deviation is less, it means average is significant, and if deviation is more, that means average is not significant. So that is the purpose of dispersion. So in case of dispersion, we have two types of measures. We have two measures of dispersion. One is absolute measure of dispersion, another is called relative measure of dispersion. First, understand the meaning of absolute measure and relative measure. Now, absolute measures are those which are expressed in same form, expressed in same form in which unit of items are given. Expressed in same unit in which expressed in same form in which items are given, or we can say they are expressed in same unit in which items are given. For example, if I have given height and height is given in centimeters, so whatever the absolute measure I compute, the answer will be in centimeters. If the height is in inches, then my absolute measure will give answer in inches. That means the absolute measures are defined in same unit in which items are given. That means it is dependent upon unit of measurement. Dependent upon unit of measurement. So they are dependent upon unit of measurement. But relative measures are expressed in pure form. Pure form means that is either expressed in ratio or in percentage or in fraction form. All these forms are independent of unit of measurement. Independent of unit of measurement. Like suppose if I say I have been given height in inches. Height in inches. So my absolute measure will give answer in inches. Absolute measure will give answer in inches. But my relative measure will give answer in the form of either 54 percentage or 0.4 or 7 by 9 in this way, which is independent of unit of measurement. This is called relative measure. So in case of absolute measure, if I have given two heights, one is in inches and one is in centimeters, I cannot compare the absolute measure of both the series because both are defined in different units. And for comparison, it's necessary that the item should be defined in same unit. So I can't compare it. But in case of relative measure, now suppose my height in inches, say the dispersion is 0.54 and the second series says my dispersion is 0.74. So I can easily compare which series has more dispersion or which series has less dispersion. That is the benefit of relative measure of dispersion. So we have two measures. One is absolute measure, another is relative measure. I have already explained you the difference between the both. Absolute measure is dependent upon unit of measurement. So we can't compare the two series which are having different units of measurement. But in relative measure, they are expressed in pure form, which is independent of unit of measurement. So we can easily compare the relative measure of more than two series. So what are the various methods we use in dispersion? In case of absolute measure, we have range. Second one is quartile deviation. Third one is mean deviation, and fourth one is standard deviation. So these are four absolute measures: range, quartile deviation, mean deviation and standard deviation. And when we talk about relative measure of dispersion, we have coefficient of range, coefficient of quartile deviation, coefficient of mean deviation and coefficient of standard deviation. So these are the four methods in case of relative measure of dispersion. Now let's discuss all these methods one by one. So let's start with the first one. That is, I have already discussed this, the difference between absolute and relative measure. Now let's discuss with the first method, that is called range. So what is range? It's very simple thing. Range is difference between largest and smallest item of the series. So range is difference between largest and smallest item of the series. So we can say range is L minus S, where L is largest item and S is the smallest item. So difference between largest and smallest item of the series is called range. And when we talk about coefficient of range, relative measure, so what we'll do, L minus S upon L plus S. So if you want to put in fraction format, you can put it in this way. And if you want to calculate in percentage, then you can multiply it with 100. You will get the value in percent. So let's solve the range in case of different series. We have individual series, discrete series and continuous series. So let's explain the range in all the three series. So first one is individual series. So let's explain it with question. We have been given this series. This is my individual series in which just the items are given. So we have to find out range and coefficient of range. So range is difference between largest and smallest item of the series. So find out the largest and smallest item among the series. So if we just look at the series, 35 is the largest item and 15 is the smallest item. So let's do it. Largest item is 35. Smallest item is 15. So range is 20. This is called range. And when we talk about coefficient of range, so the formula for coefficient of range is L minus S upon L plus S. So this is 35 minus 15 upon 35 plus 15. So this is 20 upon 50. So here you can put it in this way, 2 by 5, or you can write 0.4, or you can multiply it with 100, then it becomes 40%. All these three answers are correct. So you have to just look at the option in which form your answers has been given. If it is in fraction form, the answer is 2 by 5. If it is in ratio or fraction form, if it is in simple form, that is 0.4, or if it is in percentage form, the answer is 40%. This is your individual series. Now let's move to discrete series. So in discrete series, we have been given X, marks, and frequency, number of students. Now we have to find out the range. Now range is again difference between largest and smallest item of the series. So in this case again you have to find out the largest item of the series as well as the smallest item of the series. So for that you don't need to have a look at the frequency. You have to just look the items, that is marks X series. So when we are looking to the over the marks, we got that 10 is the smallest item and 70 is the largest item. So range is L minus S. So this is 70 minus 10, that is equal to 60. So this is called range. So this is my absolute measure. So here marks are given. So marks do not have any unit. That's why we write 60. If instead of marks we have been given weight. So that will be in 60 kg. So whatever the units items has, the absolute measure will be defined in same unit. So when we talk about coefficient of range, so this means L minus S upon L plus S. So L minus S is 70 minus 10 and L plus S is 70 plus 10. So this is 60 upon 80. So we can write it in this form 3 by 4, or we can write it in the form 0.75, or we can write it in the form 75%. All three are correct answers. These are the relative measures. Now next we have continuous series. So in continuous series we have in class interval. Again you have to find out the largest and smallest item of the series. So you have to look just at the class interval. The lower limit of the first class is your smallest item and the upper limit of the last class is your largest item. So 30 minus 5, our range is 25. And if we want to compute coefficient of range, then our answer is L minus S upon L plus S. So this is 30 minus 5 upon 30 plus 5. So answer is 25 upon 35. This becomes 5 upon 7 or 0.7 or 70%, whatever the answer is. Now next thing is, now just look at the question. Now just look at the question. We have to find out the range of this series. So in that case, this series is inclusive. Inclusive means the upper limit of this class and the lower limit of this class is not same. This is called inclusive series, means upper limit is included in the class. But whenever you have to find out absolute measure or relative measure, you must convert the series into exclusive classes. So I have already told you how to convert inclusive class into exclusive class. This is lower limit of second class minus upper limit of first class divided by 2. So lower limit of second class is 11, upper limit of first class is 10 divided by 2. So this is 1 by 2, that is equal to 0.5. So now what you have to do, you have to subtract this correction from lower limit and add it into upper limit. So your exclusive class interval becomes 5.5 to 10.5. 10.5 to 15.5, 15.5 to 20.5, 20.5 to 25.5 and 25.5 to 30.5. Now this is my exclusive class. Now with this class interval I have to calculate range. So my lowest item is 5.5, smallest item. My largest item is 30.5. So my range is 30.5 minus 5.5, that becomes 25. So if you compute range without converting into exclusive class, then your range will be 30 minus 6, 24, which is wrong. So make sure if you have an inclusive class series, first convert it into exclusive class, then calculate the absolute as well as relative measure. So our absolute measure range is 25 and our relative measure coefficient of range is L minus S upon L plus S. So this is 25 upon 36. So simply say 25 upon 36 or just convert it into decimals. So this is range. Now next thing is properties of range. Now this is very important, the various properties of range. The first property, if all the observations are equal, so if I say 10, 10, 10, 10, 10, I'm discussing the first property. So my range is, my largest item is 10, my smallest item is 10, so L minus S, 10 minus 10, that is equal to 0. Then range is 0. This is my first property. If all the items are same, then range is 0. Now second thing is, range is dependent on change of scale but independent of change of origin. Now please again understand this concept. It says range is not affected by change of origin, but it is affected by change of scale. ठीक है, range is affected by change of origin but it is not affected by change of scale. What it means, suppose we took 5 items, 5, 7, 11, 14, 19. So my range is, largest item is 19, smallest item is 5, so my range is 14. Now what I have done, I have added constant 2 in all the items of the series. This becomes 7, 9, 13, 16, 21. So now the range becomes largest minus smallest item, 21 minus 7, that is 14. There is no change in the value of range. Then I say x minus 2. Now x minus 2, I have subtracted 2 from all the elements of the series. So this becomes 3, 5, 9, 12, 17. So my range becomes 17 minus 3, 14. Again the range remains the same. So I have already told you, range is independent, not affected by. Change of origin means adding a constant or subtracting a constant won't affect the value of range. This is called independent of change of origin. But when we talk about change of scale, that means if I multiply the entire series by 2, so my series becomes 10, 14, 22, 28, 38. My range is, the largest item is 38, the smallest item is 10, so this becomes 28. My old range is 14, so it is doubled by the oldest one. That means multiplied by 2. So median is dependent, range is dependent of change of scale. Now I just explain you one more thing. If I multiply x by minus 2, so multiplying all the items by minus 2, this becomes minus 10, minus 14, minus 22, minus 28, minus 38. So in that case, my range becomes, now when we multiply the entire series by negative amount, then you have to keep in mind that your largest and smallest item interchange with each other. In case of negative items, the smallest negative item will be the largest item and the largest negative item becomes the smallest item. So range becomes minus 10 minus 38. So this becomes minus 10 plus 38, that is equal to 28. That means this negative sign won't affect the value of range. That is the most important thing. So if you have been given this equation y equals to a plus bx, here a is origin and b is scale. Beta, whenever you compute mean, median, mode, then you know that mean, median, mode are both affected by origin as well as scale. So simply you substitute this equation by the mean, median, mode value of x. But when we talk about dispersion, so dispersion is not affected by origin. So this will be ignored. We have y equals to bx. But I have already told you the sign of b won't affect your range. So that means range of y that is equal to mod of b into range of x. So if the value of b is positive or negative, it won't affect. You just took the positive value of b and multiply it with range of x. So this is the most important property of range. Now suppose if I'll give you one example. Y equals to minus 2x plus 30. If range of x is 12, find range of y. So I've already told you range is not affected by origin, so this will be ignored. Range is affected by scale, but sign doesn't matter. So that means range of y equals to minus 2 has been put into mod into range of x. So minus 2 becomes 2 and range of x is 12. So our range of y is 24. So this is the property of range. I hope I have explained you this very important property of range. Range is independent of change of origin but dependent of change of scale. Okay? And range is not treated as ideal measure of dispersion because range basically computed through extreme values only. It is based on two observations only. So these are the properties of range. Now let's move to merits and demerits. So again we are just repeating the same properties that we have discussed in average. Range is rigidly defined. Unique value, whenever we compute range we have just one value, so range is rigidly defined. Okay, so next is very easy to calculate, simple to understand. This is the most simple way to compute dispersion, easy to calculate and simple to understand. And the most important property is range is used in statistical quality control. Now, wherever you have to impose some quality standards, in that case we use range. Like suppose we have been given, we have a product in which we have been listed that the minimum content of a particular element is this and maximum content will be this. So whenever you go for blood tests, then they always give you the range. Minimum value is this, maximum value is this. So your HB should be minimum this, maximum this. Your TSH should be minimum this, maximum this. Your TLC should be minimum this, maximum this. So range is basically used in statistical quality control. So these are the merits of range. When we talk about demerits, beta range is not based on all the items of the series. Not based on all the items of the series. We just simply consider the range items, the extreme item, the smallest item and the largest item. So it is not based on all the items of the series. It is most affected by extreme items because range is calculated with the help of extreme items only. So it is most affected by extreme items. If extreme items changes, our range value also changes. Now suppose in series number 1, the minimum value is 5 and maximum value is 90. So our range is 85. Now suppose in the same series we say that instead of 5 it's 50 and the maximum value is 90, the range becomes 40. So there is a drastic change in the range. So series is most affected by, range is most affected by extreme items. Similarly, range is most affected by sampling fluctuations. Most affected by sampling fluctuation. There may be cases when the multiple samples taken from one population has different range. So range is most affected by sampling fluctuation. Range cannot be calculated. Range cannot be calculated in case of open-end series. Because in open-end series, you haven't given the range items. The lower limit of first class is missing and the upper limit of last class is missing. And we generally compute range with the help of these two items. So range cannot be computed in open-end series. cannot be computed in case of qualitative data. Okay, so these are the demerits of range. So this is the first measure of dispersion that we have discussed, that is called range. So now after range, we'll move to the second measure, that is called quartile deviation. So quartiles we have discussed in averages, like this is the series. So quartiles are basically that divides the entire series into four equal parts. Divides the entire series into four equal parts. So we have, this is Q1, this is Q2, this is Q3, and this is Q4. So I've already told you Q1 comprises of 25% of items, Q2 comprises of 50% of items, and Q3 comprises of 75% of items. We never consider Q4 because it almost comprises of 100% of items. So when we talk about quartiles, we talk about two quartiles, one is Q1 and another is Q3. Because Q2 defines median. So quartile deviation basically computes deviation among between Q1 and Q3. And Q1 and Q3 it comprises of 50% items. 25% items are ignored here and 25% items are above Q3, so they are ignored. So basically the main crux is quartile deviation computes deviation among middle 50% of items. Among middle 50% of items. So in case of quartile deviation, we compute three items. One is called interquartile range. This is Q3 minus Q1. Second, we compute quartile deviation. That is Q3 minus Q1 upon 2. And third one is coefficient of quartile deviation. That is Q3 minus Q1 upon Q3 plus Q1. If you want to compute in percentage, then multiply it by 100. Otherwise, you can ignore 100 as well. So these are the three formulas which we use in quartile deviation. One is interquartile range, Q3 minus Q1. Quartile deviation, Q3 minus Q1 upon 2. And coefficient of quartile deviation, that is Q3 minus Q1 upon Q3 plus Q1. Now let's compute the quartile deviation. Again, we have three types of series: individual, discrete and contiguous. I have already explained you how to compute quartiles in case of different types of series. So let's revise it, and along with that we can compute quartile deviation. So this is my individual series. So whenever you have to compute partitional averages, the first step is arrange the series in ascending order. So this is the series. So first we'll arrange them in ascending order. So when we arrange it, this becomes 15, 16, 18, then we have 28, 30, 32, 40 and 45. So these are my items which are arranged in ascending order. So first find out n. How many items are there? So we have 3, 3, 6 to 8 items. So sorry. So next step is find the rank of quartiles. So how we can find out the rank of quartiles? This is k n plus 1 by 4. So if we want to compute the rank of Q1, so Q1 k is 1, n plus 1, 8 plus 1 by 4. So 9 by 4, this becomes 4 to 8, 2.25. So I have told you how to compute Q1, that is second item, plus 0.25 of third minus second item. So second item is 16, plus 0.25 of third item is 18 and second item is 16. So this becomes 16 plus 0.25 into 2.5. So this becomes 16.5 Q1. And if we want to compute Q3, so first we have to compute the rank of Q3. 3 into 8 plus 1 by 4. So this becomes 6.75. So Q3 is equal to 6th item plus 0.75 of 7th item minus 6th item. So 6th item is 3, 4, 5, 6, 32 plus 0.75 of 7th item is 40 minus 32. So we have multiplied 8 into 0.75, that becomes 6. So this is 38. So Q1 is 16.5 and Q3 is 38. Now compute interquartile ranges Q3 minus Q1. So Q3 minus Q1 is, so we have Q3 is 38 and Q1 is 16.5. So this becomes 21.5. If we want to compute quartile deviation, that is Q3 minus Q1 upon 2. So 21.5 divided by 2. So this becomes 10.75. And if you want to compute coefficient of quartile deviation, so this is Q3 minus Q1 upon Q3 plus Q1. So 21.5 upon, नीचे हमने दोनों को ऐड करना है, we have to add both the items, so this becomes 54.5. So answer is 21.5 divided by 54.5. So this becomes 0.39. 0.394. This is called coefficient of quartile deviation. This is how we can compute quartile deviation in case of individual series. Now let's move to the second series, that is discrete series. So the method of computing quartiles: first, arrange the series in ascending order. Just look at the series. Our series is already in ascending order. Second thing is find CF, cumulative frequency. So if we compute cumulative frequency, this becomes 5, 7, 10, 18, 22 and 25. Now next thing is rank. Find rank. Rank is k n plus 1 by 4. Now if we want to compute Q1, so this becomes n plus 1 by 4. Now here n is total frequency. So total frequency is 25 plus 1 upon 4. 26 upon 4. 26 upon 4 becomes 6.5. So 6.5 lies in which CF? It lies in 7. So the item in front of that, that is a Q1. So Q1 is 20. And if we want to compute Q3, so that is 3 into n plus 1 by 4. So this is 3 into 26 by 4. So this becomes 19.5. So 19.5 lies in cumulative frequency, that is 22. So the item in front of that, that becomes your Q3. So Q3 is 50. So we have computed Q1 and Q3. So interquartile range is Q3 minus Q1. So this is 50 minus 20, that is 30. Second thing, we have to compute quartile deviation. So that is Q3 minus Q1 upon 2. So that is 30 upon 2 equals to 50. And next we have coefficient of quartile deviation. This is Q3 minus Q1 upon Q3 plus Q1. So this is 30 upon 70. So this becomes 0.427. So this is your discrete series. Now let's move to the third one, that is continuous series. Again, in case of continuous series, the first step is arrange the series in ascending order. So if we look at the question, our class intervals are already in ascending order. The second thing is you have to find out cumulative frequency. So cumulative frequency is 10, 22, 30, 50, 61, 65 and 70. So this is our cumulative frequency. The third step is find rank. So rank is, in case of continuous series, it is kn by 4. So n is total frequency. So if we want to find out the rank of Q1, this becomes 70 by 4. So 75 by 4 means it's 4 ones are 4, 3, 4 sevens are 28, 17.5. So 17.5 lies in which CF? It lies in 22. So 25 to 30, this is your Q1 class. Means your quartile 1 lies in 25 to 30. So let's compute Q1. The formula for Q1 is L1 plus rank minus cumulative frequency of previous class upon frequency of quartile class into class interval. So L1 is 25. N by 4 is, we have just computed it, 17.5 minus cumulative frequency of previous class, that is 10. Frequency of quartile class, this is 12 and class interval is 5. So this becomes 25 plus 5.5 upon 12 into 5. Sorry, it's 7.5. So let's compute 7.5 into 5 divided by 12 plus 25. So this becomes 28.125. This is your Q1. Now in the similar way, find out Q3. So Q3 is 3n by 4. So 3 into 70 by 4. So this becomes 3 5s are 15, 3 7s are 21, 22, 3 1s are 3, 4, 5, 52.5. So 52.5 lies in 61. So this is our Q3 class 40 to 45. Now simply put the value, lower limit 40 plus rank minus cumulative frequency of previous class upon frequency of Q3 class into class interval. So this becomes 40 plus 2.5 into 5 upon 11. So let's start. 2.5 into 5 divided by 11. So this becomes your 1.1363. So this is 41.136. So this is Q3. Now we have computed Q1 and Q3. So interquartile range is Q3 minus Q1, 41.136 minus 28.125. So this is 110, 41 minus 28, 13.011. And when we say quartile deviation, so this is Q3 minus Q1 upon 2. So 13.011 divided by 2. So this becomes 6.505. And when we say coefficient of quartile deviation, so this is Q3 minus Q1 upon Q3 plus Q1. So this is 13.011 divided by the addition, sum of both the equations. So both the Q1 and Q3. So this becomes 69.2561. So just divide it, this will be your answer. This is how we can compute quartile deviation in case of individual series, discrete series and continuous series. One thing remember, the most appropriate measure most appropriate measure of dispersion. Measure of dispersion in case of open end series. In case of open end series, that is quartile deviation. So whenever you have been given open end series in which the lower limit of first class or the upper limit of last class or both is missing, then you have to apply quartile deviation. If the question is silent, simply apply quartile deviation. Next we'll discuss the properties. So properties, I have already explained you. In case of open end series, the best measure of dispersion is quartile deviation. It is less affected due to sampling fluctuation. It is less affected due to extreme items. And the most important property is quartile deviation is independent of change of origin, but dependent on change of scale. Now again the same thing, if we add or subtract a constant from the series, then quartile deviation remains same. But if we multiply or divide a constant among all the items of the series, the quartile deviation changed. So this is called independent of change of origin and this is called dependent of change of scale. Again, the scale, the sign of scale doesn't matter. Whether it is positive or negative, it won't affect your quartile deviation. So if the equation is y equals to a plus bx, where a is change of origin and b is change of scale. So you know that quartile deviation is not affected by change of origin. We simply ignore it, but it is dependent on change of scale. So quartile deviation of y is equal to mod of b into quartile deviation of x. So suppose you have been given equation y equals to 2 minus 5x. If quartile deviation of x is 4, find quartile deviation of y. So that means mod of b means mod of minus b into quartile deviation of x. So 5 into quartile deviation of x, which is 4, your answer is 20. So sign of scale doesn't matter, just keep it in mind. Sign won't affect the sign of quartile deviation. So this is quartile deviation. Now next we have merits and demerits. Quartile deviation is simple to understand, easy to compute. It is less affected by extreme items because quartile deviation basically computes deviation among middle 50% of items. And extreme items are either both at the extreme ends and quartile deviation won't consider them. So we can say that this is not affected. If we write down not even, then it's fine, not affected by extreme items. It is least affected by sampling fluctuation. Least affected by sampling fluctuation. This is best measure in case of open-end series. So if your series is open-ended, the best measure is quartile deviation. And I've already told you that it computes deviation among middle 50% of items, which is as compared to range, it's a merit, but as compared to other measures, it's a demerit. So next we have demerits. It is not capable of further algebraic treatment. We can say it's rigidly defined. So rigidly defined, again it's a merit. Rigidly defined. Okay, so this is a merit. And if we say demerits, it is not based on all the items of the series. It computes deviation among middle 50% of items. It's on all items of series. It is not capable of further algebraic treatment. It's wrong. It's not least affected by sampling fluctuation. Then we don't write it down in the demerit. So it is not capable of further algebraic treatment. Computes dispersion among middle 50% of items. ठीक है, all these are demerits. So this is all about quartile deviation. So that's all for today. Now we have just two measures. One is mean deviation and standard deviation that we will discuss in the next class. Now if you have any query, any question, you can ask Bacha. If you have any query, any doubt, please raise your doubt. Now please, any question, any doubt? Okay, fine. So that's all. Srishti ma'am. Srishti ma'am. Thank you.